Good morning. Today's math lesson is going to be on using the Pythagorean theorem to solve problems, word problems. And so our do now is the cost of candy varies directly with the weight of the candy in the bag. 2.5 pounds of candy costs $3.25. What is the cost in dollars of a 5.5 pound bag of candy? So we can solve this problem several different ways, but I'm going to solve it using the woe chart. The W stands for the words or the units. So the units in this problem are pounds. And I'm going to use LBS as my abbreviation for pounds, as well as money. And the O stands for the original numbers on the problem. So I have 2.5 pounds of candy. So I'm going to have 2.5. And then $3.25, so 3.25. Then the E column stands for equivalent. And so we have to figure out the equivalent proportion or the equivalent value to that side of the proportion. So we have the number of pounds, which is 5.5. And we're trying to figure out the cost. So I'm going to put X to represent the cost. From here, I can write my proportion because everything in the O column goes in the left side of the proportion. So we have 2.5 over 3.25. And then we have 5.5 over X. Now I'm going to cross multiply and divide, otherwise known as the butterfly method. I'm going to draw the wings. So we have 2.5 times 5 is 2.5, or 2.5 times X is 2.5X. Then we have 5.5 times 3.25, which is 17.875. Now to get the X alone, we're going to have to get the 2.5 to the other side. So right now we're multiplying by 2.5, so we're going to do the opposite to move it over, and that is dividing. So we're going to divide both sides by 2.5. 2.5 divided by 2.5 is 1, so we can cross those numbers out and we're left with X. Then we have 17.875 divided by 2.5, and that is 7.15. So our answer is the 5.5 pound bag of candy is going to be $7.15. Today's TEK is 8.7c. Our lesson target is that scholars will use the Pythagorean theorem and its converse to solve problems. And so converse is just when you change around the numbers or the variables, the letters in a problem when you manipulate it. And the DOL is given 4 problems. Scholars will use the Pythagorean theorem and its converse to solve problems with 100% accuracy. Just as a review from yesterday's lesson, our hypotenuse is going to be this longest side on the right triangle, and it's usually represented with the letter C. The legs are what we previously knew as the height and the base lengths of the right triangle, and they're represented with the letters A and B. Right triangles, of course, have a right angle. And the Pythagorean theorem equation is this a squared plus b squared is equal to c squared, and that's just something you're going to have to memorize. We use the square root to solve if we know the area, but we're trying to find the specific side length. So, for example, the square root of a squared is equal to just a, since the square root and the square cancel each other out. And if we use a number there, let's say we have 3 squared, 3 times 3 is 9. So if I square root each side, the square root symbol and the 2 cancel each other out, so then I'm left with 3 is equal to the square root of 9. And if you think about it, what number times itself is equal to 9? That's 3. 3 times 3 is equal to 9. So again, converse is when we can flip around or manipulate this equation to find what we're actually looking for. And so we'll get into that in later problems. So if we're trying to find like one of the missing side lengths of the leg and we know the other leg as well as the hypotenuse, we're going to have to manipulate and use the converse of the Pythagorean theorem to solve for that. So this first activity is using your calculator, complete the following table. So we have the values of a, b, and c, and we have to fill in a squared, b squared, a squared plus b squared, and then c squared. So for this first row, 3 squared, or 3 times 3 is 9. 4 squared, 4 times 4 is 16. 9 plus 16 is 25. And then if we did 5 times 5, which is 5 squared, that also gives us 25. So we can see just from this first example that a squared plus b squared, the value of it is equal to the value of c squared. Then if we have the second row, 5 squared, 5 times 5 is 25. 12 squared, 12 times 12 is 144. 25 plus 144 is 169. 13 squared, 13 times 13 is also 169. And so this is another example of how a squared plus b squared, the value of that is equal to the value of c squared. Then if we have 7, 24, and 25, 7 times 7 or 7 squared is 49. 24 squared, 576. 49 plus 576 is 625. And then if we did 25 squared, which is 25 times 25, that's also 625. If we do 8 squared, 8 times 8, that's 64. And then 15 squared, which is 15 times 15, is 225. If we add together 64 plus 225, we get 289. 17 squared, which is 17 times 17, is 289. And then our last row, we have A is 9, B is 40, C is 41. 9 squared is 9 times 9, which is 81. B squared is 40 times 40, which is 1600 or 1600. And 41 squared is 41 times 41, which is 1681. If we add together 81 plus 1600, we'll also get 1681. So all of these A, B's, and C's, like all the numbers together, are considered Pythagorean triples. So triples because there's 3 numbers, and Pythagorean because if you input the numbers as A, B, and C, they'll give us values that make it so that it works in the Pythagorean theorem. This algebra reads the width of a rectangular TV is 27.2 inches and the length is 43.9 inches. What is the measurement of the diagonal of this TV in feet? So the first thing that I'm going to do is label the sides A, B, and C. So I know that the diagonal that they're talking about is going to be our hypotenuse, which is going to be our C value. And then our height is our A, and our base is our B value. So now I'm going to write out my Pythagorean theorem equation, which is A squared plus B squared is equal to C squared. And then I'm going to plug in the numbers. So our A was 27.2. So we have 27.2 squared. Plus our B is 43.9. So we have 43.9 squared is equal to C squared. So now I have to solve for 27.2 squared and 43.9 squared. So 27.2 squared, which is 27.2 times 27.2, is 739.84. I just rounded to the nearest hundredths place. And then 43.9 square, 43.9 times 43.9 is 1,900 27.21. Now I have to add together these numbers. So when I add together 739.84 plus 1,927.21, I get 2,667.05 is equal to c squared. And if I just want to figure out the value of c, because this right here is saying that the square, the area of the square that uses c, or that hypotenuse, as a side length is 2,667.05. But if we just want to figure out the side length of that square, we're going to have to square root it, like we learned or talked about yesterday. And so you can just use a calculator for this. And so if we round our answer to the nearest hundredths place, we'd get 51.64 is equal to c. And in this case, our units were inches. So this symbol right here represents inches in math. For this next IG, we're going to have to use the converse of the Pythagorean theorem because, as you can see, we're given a leg, side length, and then the hypotenuse, and we're trying to find the other leg. So this IG reads, the measures of the width and the diagonal of a credit card are shown in millimeters. What is the length of the credit card in millimeters? So the first thing that I'm going to do is, again, label each side. So this height of the triangle is going to be my A value. This base length is going to be my B value, and then of course my hypotenuse is going to be my C value. I'm going to write out what my Pythagorean theorem equation is, which is A squared plus B squared is equal to C squared. Then I'm going to plug in the numbers. So my A was 52, so I have 52 squared plus B squared is equal to 96 squared. Now I have to solve for 52 squared and 96 squared. So 52 squared is 52 times 52, 2,704. I still have to have the b squared, so I'm going to write plus b squared is equal to 96 squared is 96 times 96, which is 9,216. And now I want to move over this 2,704. And so to do that, I'm going to have to do the opposite operation. The opposite of adding by 2,704, or by the opposite of positive 2,704, is negative 2,704, or subtracting 2,704. So that's what I'm going to do on both sides of the equation. (2,704) minus 2,704 is 0. So then we have b squared is equal to 9,216 minus 2,704 is 6,512. And so now I have b squared is equal to 6,512. That's telling us that the area of the square that uses b as the side length is 6,512. But to just find that side length, we're going to have to square root it. So I'm going to find the square root of 6,512. So again, when you see a square root symbol as well as the squared symbol, the little to the power of 2, that crosses each other out. So then we're left with b is equal to the square root of 6,512 is 80.7. And in this case, our unit is millimeters. There are several UDO problems. And then there's even a quick write where you would have to verbally write out how you would find the missing measurement x, so one of the legs, what you would do. And then lastly, your Google form DOL. Thank you so much for following along in today's math lesson, and see you in the next math video. Bye.